Developers in precision farming waste countless of hours integrating ISOBUS and sensor protocols. But what if you could skip it all and focus only on what makes your autonomous system truly smart? Stay tuned to see how RTMaps is redefining application development in the field of agriculture. Hello, and welcome to today's hands-on walkthrough. My name is Peter Ngure, and I am a product manager for RTMaps here at dSPACE.
And my name is Lazar Lachev, and I am project engineer at dSPACE. Today, we want to present a short demonstration showing how we enable the development of an ISOBUS implement using RTMaps.
As the agriculture industry trends towards precision farming and autonomous driving, the complexity of developing application keeps on increasing. Developers are churning millions of lines of code, and the projection is that with the onset of software-defined vehicles, this could potentially scale to billions of lines of code. Essentially, one of the most important questions for the agriculture stakeholders is, how can you accelerate development of your applications? There are many tasks that are important to handle, but unfortunately, they are not differentiating features for your applications. For instance, handling communication protocols such as ISOBUS, CAN, and CAN-FD, and many others. Development of LiDAR, camera, radar, and other sensor interfaces. And guaranteeing application portability across different hardware and software architectures. dSPACE offers a solution called RTMaps, which is a software development and execution platform. The tool facilitates visual local development with over 600 input-output interfaces implemented out of the box so that developers can focus on the differentiating features. Support for industry standards such as ROS, AutoZAR, and DDS. Hardware and operating system abstraction so that applications can be deployed seamlessly on systems regardless of their hardware and software architecture. And now RTMaps adds an initial support for ISOBUS. Now let's dive into the practical side of things. My colleague Lazar is going to walk us through a demonstration showing how RTMaps enables development of an ISOBUS implementation and how it integrates seamlessly into a smart sprayer system. Over to you, Lazar.
Like Peter mentioned, I am going to present a short demonstration showing how we enable the development of an ISOBUS implement using RTMaps. First, let's look at the hardware architecture. We have a PC connected to an NVIDIA embedded board. The tractor simulation is running on the PC, and the PC is also used for RTMaps remote access and visualization. The application runs in the RTMaps runtime environment of the NVIDIA embedded board. This way, we can upload the application from the NVIDIA board to the real ECU without any changes later. The PC and the NVIDIA board are connected via CAN bus and Ethernet bus. The CAN bus is used for ISOBUS communication. Ethernet is used for RTMaps remote access and visualization. Now we want to show the tools that are used. The ISOBUS implementation is developed with the RTMaps Studio. To simulate the tractor site, we use ISOSimulate TC and ISOSimulate TECU from OSB Connective. The visualization of the algorithm is done in Lichtblick. Here you see the RTMaps diagram for width detection and nozzle activation. In this diagram, we are using the newly implemented ISOBUS components. The first component is the control function. With it, we can configure the CAN channel and the control function parameters. Using the TECU client, the application communicates with the tractor ECU. This way, it provides the actual speed. Processing of additional values is also possible, but not needed for our use case. The tractor speed is used by the camera player and the width detection. The nozzle activation uses the TC client to communicate with the tractor. the TC client can be configured with a DDUP file in a binary or XML format and provides access to device process data. The other part of this diagram is the visualization part in Lichtblick. Now we can start the diagram and see how it works. First, the TC client must be connected to the TC server. The TC client sends the DDUP to the task controller server during activation. We start the task and activate the section control. The boom with the sections is shown in the task controller view. The application must be configured and prescription control must be started. As you can see, the tractor is driving across the field. Let's have a look at the visualization. In Lichtblick, the field is displayed and the user can monitor width detection and nozzle activation. The tractor is moving across the field and the nozzles are activated only when weeds are detected. In addition to nozzle control, other simulation parameters are displayed. Using the TECU server, the tractor speed and the direction can be changed. That was a quick look into how RTMaps simplifies ISOBUS integration in precision farming. I will now hand back to Peter.
Thank you, Lazar. As you have seen from the demonstration, RTMaps allows for out-of-the-box support of ISOBUS, simplifying integration in your projects, abstraction of software and hardware architecture, giving your application the required portability, and an overall simplification of your application's development, thereby allowing you to only focus on the differentiating features of your application. For more on RTMaps and how to take your projects to the next level, feel free to reach out to us or directly download RTMaps evaluation and test the tool for yourself. Thank you for watching.
dSPACE, your partner in simulation and validation.